MALDI imaging is acquiring mass spec data in a spatially resolved manner from the surface of any sample. The samples we are focusing on, and that's also because the advantages of the new instruments are lended to it, is analyzing tissues, and in particular human tissue samples. And there we are trying to elucidate new biomarkers to look at disease stages or responsiveness to certain drugs for patients. So we have just recently released a next generation MALDI TOF system, and very briefly said, there's two big achievements in the new system that we have. It's, first of all, it's speed of acquisition, and that's really not an incremental improvement, it's really a quantum leap forward. We are now about 10 to 20 times faster than the last generation of instruments, which means that we can acquire in an imaging run now up to 40-50 pixels per second. And that is a substantial achievement because it increases the throughput. And coming along with that is the second achievement, is the improvement of the robustness of the instrument, because if you have this amount of throughput running through that amount of samples, then of course you want a robust instrument, because you want it to be continuously operating. If it has a lot of downtime, all the speed's not going to help you in an actual lab situation. It potentially offers a quick and easy way to identify biomarkers that were elucidated by tissue typing. So a first step is typically a differential experiment, and you're looking for differences, for example, between a treated and an untreated sample. But then typically the question is, if you found a difference, how do you identify those peaks? How do you pin a name, a molecular name on that? And the MSMS capability is a potential way to easily get that information directly off tissue. This is the point where now our main focus is to identify assays where we can either be quicker or more successful than existing technology.